Hi and welcome to this on Maths prediction for the Paper 2 higher tier Edexcel GCSE Maths paper. Enjoy! Hi, I'm Chris Gilpin and I hope that paper 1 went well. From what people are messaging me, it seems that it went okay. But a lot of you are looking to revise for paper 2 and 3. Now remember, paper 2 and 3 are not really that different to each other. It's basically a 3-hour paper split into two. So when you revise for paper 2 and 3, as long as you've got a calculator in your hand, you're good to go. Don't forget that all of the stuff that we're going to see in this video you can do on the site, completely free. If you go to onmaths.com, I'm sure there's a link coming up there now, and on the site also there's topic busters. In fact, we're finding that on the site many people are now going to the topic areas and revising specific topics, which is fantastic. Like I always say, don't rely on this prediction as an absolute this is what will come up. It never works that way. What this prediction does is it first of all gives you some practice of GCSE style questions. It also, I've removed all the stuff that's come up in paper 1 so that you can practice the topics that are more likely to come up. Especially ratio and proportion. Don't think because ratios or proportion questions come up that it can't come up again. All the exam boards have shown that they have repeated some topics. Probability is a good example as well, because probability has loads and loads of different types of question, and although probability may have come up in paper 1, it doesn't mean it can't come up in paper 2 and 3. So the safest bet is first of all focus on the calculator questions, because it's unlikely there's going to be ones that require not a calculator but you've got a calculator in your hand. They're not going to come around and take the calculator off you. These are now both calculator questions. So during this half term and during up until the exams, have your calculator in your hand. That's your best friend now. You don't need to worry about the non-calculator questions. Other than that, revise everything. If you go to our site, there's loads and loads more stuff. We're adding more stuff all the time. Such as demon questions, the revisionator, etc, etc. We're making a few changes to the site, so please just have a look on the front page and just see what's going on, and I hope you enjoy this video. Thank you very much. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally 6 6 digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to 2 significant figures. Now, to do 2 significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in your answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0, and actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have 2 shoots coming from it. Now, I need to find out which 2 numbers times together to make 88. Now, a little tip, if you've got an even number, always pick 2. So 2 times 44. Now, whenever we get to a prime number, we always circle it, because that's finished. So 44, we can get another 2 out of that. We'll divide another 2 out of that. So 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out because that will give you 88, so 2 cubed times 11 is 88. Now the thing to notice in this question is that the 2 sides of the ratio are different units, so the first thing to do is make them the same unit. Now I know that 1 kilogram is equal to 1,000 grams, because kilo means 1,000, so kilometers, kilometers, kiloliters, whatever. It's always going to be 1,000 of the base unit. So first thing I'm going to do is write 200 grams to 4,000 grams, and it's better not to put units in your working out, especially. So I'm going to not put them in from now on. Now I notice there's 2 zeros there that I can knock off both of them, so I can divide them both by 100, and I get 2 to 40, and be careful with that because there's still a 0 on that. And then I can halve both of them, so I can divide them both by 2, so I get 1 to 20. So my answer is 1 to 20. Don't need the units on it. You could have converted the 200 grams to 0.2 kilograms, and then times both sides by 5. You would get 1 to 20 as well. You'd get exactly the same answer. Okay, so the main problem with this question is that people don't know what a frequency polygon is. If you know what a frequency polygon is, I think most people will get this right. Frequency polygon is basically a line graph, but you plot these at the midpoints. So the first one's going to be plotted at 40. The next one, so if you don't know how to find a midpoint, you just find the halfway value between 0 and 80, which is 40. To do it a different way, you could add the two values together and halve it, and that works just as well. So 80 plus 160 is 240, and then halve it would be 120. 160 plus 240 is going to be 400, halve it is 200. Okay, so we're going to plot these at 40, 120 and 200. Now a different way of doing it is just plotting them halfway between the two lines. So we've got a line here and a line here, so we're just plotting them halfway. So it says frequency is 11, so looking at the scale it looks like it's going up in twos, so that would be 12, 14, 16, 18 and 20, so that works. So we're going to plot it halfway between the two red lines that I've just shown, and it's going to be halfway between 10 and 12, so it's going to be about here. And they're quite forgiving as long as they understand the point you're trying to do. If you're slightly off it, they are quite forgiving with that. Okay, so 120 is halfway between 80 and 160, and it's going to be 18 tall, which will be here. And 200 is going to be up to 6. So let's plot these 8, 6, 4, 2, and so 6 is going to be here. Now we haven't finished yet, we do need to join them up with straight lines. So let's just do that to finish off the question. And there we go, that is a frequency polygon. Now a lot of people look at the word estimate and think, oh, let's just take a guess at it. The reason we're estimating is because of the first step that we have to do to answer this question. It doesn't mean that just have a quick punt and guess at it. With this question you won't be able to guess it correctly, or it'd be very, very unlikely. So we approach this the same as if it wasn't a group. However, we do have a group, so we've got to do a step first. This means that we've got a value somewhere between 0 and 4, including 4 but not including 0. Now the problem is that the first step in this method is to multiply these two numbers together, but you can't times somewhere between 0 and 4 by 14. So what we need to do first is find the midpoint. The reason we pick the midpoint is it's a good number to use to represent that group. If we assumed all those numbers were 0, then it would probably be ridiculously small. If we assume they were all 4, again it would be too high. So we assume that all those are 2 because it's right in the middle of the group, and chances are that most of them are closer to 2 than 0 or 4. So we find the midpoint of each of the groups, and the way of doing this is just adding the lowest and highest value together and dividing it by 2. Or just having a look. 4 to 8 will be 6, 8 to 12 halfway would be 10, 12 to 16 halfway would be 14, and 16 to 20 halfway would be 18. Then what we do is we get the frequencies and times them by the midpoints. So it's the same as if it wasn't a group now. So we do 14 times 2, which is 28, 6 times 6 is 36, 3 times 10 is 30, and then you can use a calculator for this, so 9 times 14, have an idea of what it's going to be. Hopefully it's 126, which it is, good. And 2 times 18, which is 36. And this is I call this the fx, although in this case we are calling the first one s, so it's the fs column. And then we need to find the sum of the fs column. So we're going to add up 28, 36, 30, 126 and 36 on the calculator, which is 256. And then we're going to sum up the frequencies, which is this column here. So 14 plus 6 plus 3 plus 9 plus 2, which is 34. And then what we're going to do is we're going to get the 256, which is all our values added together, and divide it by 34. So 256 divided by 34. And I get the answer of 7.5294 blah blah blah. And to 2 decimal places, that's going to be 7.53. Now, the reason it's an estimate, as I've said before, is that we don't know that all the values in the first group are 2. We are estimating them to all be 2, even though we know that some of them will be 1, some of them will be 3. But chances are it will balance out that it's roughly going to be about 2 in that group, and 6 in the next group, and 10 in the group after. That's where the word estimate comes. The method for doing this is how I've shown it here. I don't believe there's any other methods you can use for this. So when you have a right-angled triangle and you're given 2 of the lengths, and you're asked to find a third length, which I'm going to call x, then it's going to be Pythagoras. Be careful, because if there's an angle involved, either you're asked to find an angle or you're just given an angle on the side, then you'll be using trigonometry. So when we use Pythagoras, there are 2 methods that I know of to work it out. There's the algebraic method, which is a squared plus b squared equals c squared, and that's absolutely fine to use. I'm not going to use that method, because if you're happy using that method, go on, use it, not a problem. The only thing to remember about that method is that c must be the hypotenuse. Okay, now I'm going to do a method that doesn't involve algebra at all for people who are not very happy with the a squared plus b squared equals c squared method. So my method comes with 3 steps. Step 1 is just square every number that you have and put the biggest one first. Okay, so I'm going to do 7.1 squared and I'm going to do 4.6 squared. So on my calculator, 7.1 squared, and that equals 50.41, and 4.6 squared equals 21.16. So step 1's done, I've squared them all. Step 2 is the only choice you have to make. You either have to add or subtract. Okay, now this is where we talk about the hypotenuse. The hypotenuse is the length that's opposite the right angle. So go to the right angle, go across from it, and that is the hypotenuse. So 7.1 is the hypotenuse. Now what's special about the hypotenuse and why it has a special name is it must be the longest side. So in step 2, have a think, well, if we add them, we'll get a bigger number. Well, the hypotenuse must be the biggest side. So when you're finding another side, not the hypotenuse, you will subtract. But if I was finding the hypotenuse, so I wanted a bigger number than the other 2, then I would add. So I'm going to do 50.41 minus 21.16, and that's why in step 1 we did the biggest one first, because otherwise you'll get a negative number. So 50.41 take away 21.16, and that equals 29.25. Okay, and step 3 is a nice easy step, it's just root it. So with this one, I'm just going to press square root answer, and then I have, so I'm going to write that down, square root 29.25, and so that equals 5.4083, blah blah blah. It says it wants it to 2 decimal places, so I'm going to write 5.41 because that 8 moves that 0 up by 1. Now, last step is just check it makes sense. Well, this being 5.41 means that the 7.1 is still the longest side, so we know we've probably got it right. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what 1 part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Okay, I understand the temptation in this question to say that the answer is 0. Please do not write that. Anything to the power of 0 is not 0. Anything to the power of 0 is 1. Now you can think about this. If you do x to the power of 5 divided by x to the power of 5, then the rule is that you take away the indices when you divide them, so it's x to the power of 0, and we know that any number divided by itself is always equal to 1. So the answer to this question is always going to be 1. Just try and remember that. Anything to the power of 0 is 1. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and then we need to times by 100. So I'm going to divide that by 7,359, times it by 100. And that gives me 66.7617, blah, blah, blah. It says to the nearest percent, so that's going to be 67%. Okay, so for this question we need to work out the length of the arc, which is around here, and then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator, and I'm going to add 37 and add another lot of 37. So add 37, add 37, and that gives me 168.2826 blah blah blah. Once it's 2 decimal places, so line goes down here, and we've got 168.28. Now just be careful that you add on the extra bits. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's 2 numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are 2 numbers that fit that bill, so that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1 over 4, or a quarter. Okay, so to do this question, I'm going to start off with a number line. And I'm going to put the number given to us in the question in the middle. So 89.6. Now it says it's the nearest tenth of a second. So what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5. And the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points. and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle X. Now to find X, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SO, and it's not going to be Ka, so it's going to be TOA. So TOA stands for tan X equals opposite over adjacent, and the opposite is 47, and the adjacent is 72. Now we want to work out what X is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click Shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens a set of brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah blah blah. Okay, let's have a look. So X is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that Y. So to work out what Y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on a calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. Okay, so for this question, understanding of the formula of a circle is critical. So formula of a circle is x squared plus y squared equals r squared. So it looks very, very similar to the equation given to us here. So if I rewrite the equation given to us, and instead of 4 I write 2 squared. Okay, and that's a perfect match for the equation of a circle. So we've got a circle with radius 2. So it's from the origin, which is here. Let's do this in red so it shows up. And it will pass through, it will have a radius of 2. Now, I don't have a compass, but when you're doing this, do it with a compass, and you're going to see how rubbish I am at drawing circles. That wasn't bad, although I think it's just going to get worse. It's probably the least pathetic circle I've drawn, but use a compass in the exam. Measure out the radius on one of the axes, and then just draw a circle, and that's 4 marks. Okay, so in this question we're asked to enlarge shape A by scale factor -2 with the centre of enlargement 2,5. So normally we'd first of all put the centre of enlargement on, but it's already done for us. So what I need to do now is draw my ray lines, but because it's negative we know they're going to go through the centre of enlargement. So I'm going to draw my ray line. I don't need to do the bottom right one because it will essentially be the same thing. And let's do this one. Let's try and get it as perfect as we can. So it should be something like that. Okay, now the next thing to do is count how many squares we went away. So I'm going to start with the bottom left point. So we've got 1, 2, 3, 4 to get to the centre of enlargement. So if it's -2, we're going to go another 4 twice. So 1, 2, 3, 4, 1, 2, 3, 4. So we end up here. Okay. For the next one, let's do the bottom right one. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're just right on the edge there. Okay, let's do the last one. So this time I'm going to count the diagonals, and if you had a ruler you could just measure it out. So 1, 2, 3, 4 diagonals. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and now we need to connect them all up. So let's connect them all up. And probably it will say label it B, yeah. So label it B. And always check the width of A was 2 and the width of B is 4, so that's good. The height of it is 4, and so the height of B should be 8, which it is. And it looks unusual because for an enlargement you're used to it being the same way around, but for negative enlargement it basically just flips it. There are a few different ways of answering this question. I'm going to show you what I feel is the easiest technique, but if you've got a different technique you get the same answer, then stick with it. This question will all be about multipliers and understanding how to use them, but the difficulty in this question is we're finding out how long it will take to get to a certain point, which is a big twist in this question, and we're not given a quantity. Now whenever you're not given a quantity, one method of being able to do it is by putting in your own quantity, and the easiest quantity to put in is the number 100. So I'm going to pretend that the population of the town at the start is 100. Now this question, as I said, is all about multipliers, so we need to figure out what a decrease of 6.5% as a multiplier is. And to do multiplier, you start off with 100%, You do whatever the question's saying, so this time we're decreasing by 6.5%. And this will be on the calculator paper, so you might as well use your calculator to do 100 take away 6.5, and hopefully the answer is 93.5%. And to convert it into a multiplier, you just divide by 100. You're just converting it to a decimal, but the paper will call it a multiplier. That would be 0.935. So whenever I times something by 0.935, I've decreased it by 6.5%. Okay, so we've got 100. And what I want to do is figure out how many times I need to multiply it by 0.935. Okay, so there's a power here which we don't know yet, to get the answer that is less than 47% of it. Well, the reason I pick 100 as my quantity I've made up is because 100 is nice and easy, because 47% of 100 is 47. So we need it to be less than 47. Now, what I do on my calculator is I type in 100 and I times by 0.935 and I get the answer of 93.5. Now, what I'm going to do now, and that's one time, what I'm going to do now is press answer times 0.935. And what that will do is allow me to go through this same calculation as many times as I want by just pressing the equals button. So I'm going to press the equals button once and I get the answer of 87.42. So I've done twice in total so far, and I can leave a little tally mark here. I press it again and I get 81.7. Again, 76.4. Again, 71.4. Again, 66.8. Again, 62.4. So I'm getting closer. Again, 58.4. Again, 54.6. Again, 51. I'm getting close. Again, 47.7. So I'm getting very, very close, but I'm not quite there yet. And I press it one more time and I get 44.6. So in total, I've done it 12 times. Now, I'll always want to check that because my counting is not necessarily the best when under pressure. So what I'm going to do is I'm just going to do 100 times 0.935 to the power of 12 to check that I've got this right. So 100 times 0.935 to the power of 12, and I get 44.64. And I'm just going to check that that was the first time it went under. So I'm going to do to the power of 11. And what I can do is just scroll through my working out on the calculator and change the 12 to 11. And press equal. And that's 47.744. Blah, blah, blah. Okay, and each of these are rounded. Okay, so it's going to take 12 years because 11 years gets us close but not quite over the line. It's the 12th year that it dips below 47%. Now, as I said, there are different methods. You don't need to include the 100 as a made-up value. What you can do is just look at the multiplier and wait until the multiplier is 0.47 or below, below 0.47. And the multiplier would go down to 0.4464, blah, 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 blah. That's absolutely fine method. And there are other ways of doing divisions, which I'm not going to go into because you don't need to go that far. Because when you hit A level, there's a much, much better way of doing it, but we don't go through it at GCSE. If you wanted to look into it, it's to do with logarithms, but we won't go into that. Okay, so this question looks quite simple, but actually it's going to take a bit of time to sort out. So first thing I'll do is do a little sketch. I'm going to do it up here. Since the y's are mainly negative, in fact are negative, both negative, I'm just going to show the bottom of the graph. So at point 7, we're at minus 17, which I'm going to say is here. It's a sketch, so it doesn't have to be perfect. And at point 19, we're at minus 11, which I'm going to say is here. Okay, this is called line AB. Now we're asked for the perpendicular bisector. Now perpendicular means it's going to hit that line at right angles. Bisector means it's going to cut it right down the middle. So I'm going to start off at the middle of the shape and draw a quick sketch there, like that. Okay, I'm going to call this M here, and I'm going to call this line C, just so I can reference it in my working out, and it makes it a bit clearer. Now, there are two things I need to find out to find out the equation of point C. I need to find the gradient of point C, and I need to find the y-intercept. The gradient is going to be the first thing I'm going to have to find, and then I can work out what the y-intercept is, and then write the equation of line C. So, two things I need to work out for line AB is the gradient. So the gradient is going to be change in y over change in x. So the change in y is minus 11 take away minus 17, and the change in x is 19 take away 7. Okay, so we've got minus 11 and then effectively plus 17, which is 6, divided by 19 take away 7. Okay, 19 take away 7 is obviously 12, so 6 divided by 12, which is a half. So the gradient of that is going to be a half. Okay, next I need to find the midpoint, because we know that that's also a point on line C. Okay, so the midpoint is going to be the average of the x's, so 7 plus 19 over 2, and then the average of the y's, so minus 17 plus minus 11 over 2. So we're basically just finding the halfway points. Now, obviously 7 plus 19 is 26, divided by 2 is 13, but you might have just noticed that 13 is halfway between 7 and 19. Same with the others. Obviously, we could do the same thing. Halfway between the two of them is going to be minus 14. Okay. Now, you might be wondering, well, why did we find the gradient of line AB? Well, perpendiculars have a kind of weird connection where if you multiply both their gradients, it equals minus 1. Now, the way we use this is to convert a gradient to a perpendicular gradient. We do two things. We find the reciprocal of the gradient and we times it by minus 1. So to find the gradient of line C, what we're going to do is flip it. So the reciprocal of half is 2 and times it by minus 1. So it's going to be minus 2. Now, a way of checking that is if you multiply the two gradients together, you should equal minus 1, which a half times minus 2 is minus 1. So we've got the gradient. Now we know that a formula for the equation of line C is y equals mx plus c. We actually know the gradient and we know a point on that line, which was the midpoint of line AB. So we're going to feed in the coordinates. So it's minus 14. We know what the gradient is, minus 2. I'm going to put this in brackets, times the x coordinate, which was 13, plus c. And we just solve this to find out what c is. So minus 14 equals, and that's going to be minus 26 plus c. I'm going to add 26 both sides. And if this is on the calculator, then obviously always use your calculator to be sure. So it's going to be 12 equals c, or c equals 12. So therefore the equation is in the form y equals mx plus c. It's going to be y equals minus 2x plus 12. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach, which I'm going to use, is I'm going to work out this angle here using the sine rule, and then work out this angle here, taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first. So that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it x, so it's a bit easier to write. So I'm going to use the sine rule, and that says that sine x over, so this is sine x, this is x here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8, so it's going to be sine x equals 8 sine 110 over 12, and then what I'm going to do is inverse sine both sides. Scroll down a bit more. So x is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that x is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator, and then what I'm going to do is add that to the 110 to work out what this angle here is, and I'm going to call that y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as y, just to make it a bit easier. So y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that, then I'm going to type in 180 take away the answer. So that tells me that y is 31.2104 blah blah blah. Okay, so I've worked out what y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it. It was A and B. A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now that's why you must show you're working out, because if you got say 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. Now there are 2 things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were 2 things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here. It could be 5x plus 10. That's absolutely fine. Still the right answer. Over x plus 3. Okay, the first question asks us to find where the y-intercept. Now at the y-intercept x is 0, so if you have a look at our equation, these 2 will be wiped out because anything times 0 is 0, and we're just left with y equals minus 4. So x is going to be 0 and y is going to be minus 4, so that's nice and easy. And basically whenever you just have a number in an equation, the y-intercept is that number, so it's going to be minus 4. The next question is pretty complicated, so we're going to break this down. It does ask us to complete the square, it gives us a bit of a hint. So I'm going to start with completing the square. So we've got x squared minus 8x minus 4. And to complete the square, what we do is we put brackets and we do x, and we do half of the coefficient of b. So half of this, and b is always the number before the x. So half of minus 8 is going to be minus 4. And we close bracket and put a squared there. Now if I expand that up here, x times x is x squared. Then you have minus 4x, and plus 16. So we get x squared minus 8x plus 16. Now, we want the x squared minus 8x because that's what the equation in the question is, but we don't want this bit, that plus 16. So we're going to subtract, get rid of the 16 by taking away 16 there. And we've also got the minus 4, which is in the question to have as well. And we do have videos on completing the square which go into it a little bit more detail than I'm going through here, so watch those if you're not sure. Go put the minus 16 and the takeaway 4 together. Okay, so here we've got an x and we're subtracting 4, we're going to square that and then take away 20. Now, the next thing to think about is comparing it to y equals x squared. Okay, y equals x squared looks something like this, and I'm going to do a really bad job of doing this, but something like this, okay? And that's y equals x squared. So if you think about that function, and we're going to call that f of x, then what's happened between that and the one that we've just created? Well, in terms of f of x, this one is going to be f, which is the function is squaring, of x minus 4, okay, and we're going to square it, take away 20. So think about functions. What do the bits do? Well, anything in here moves it in the opposite direction on the x-axis. So a minus 4 would move it 4 to the right, and anything in here will shift it on the y-axis, and actually it will be in the correct direction. So anything inside the bracket affects the x in kind of the opposite direction, and anything outside the function will just affect the y. So the minimum point on y equals x squared is 0, 0. And we're moving to the right 4, and then we're moving down 20, so it'd be minus 20. So the new point will be at 4 minus 20, and that's going to be the point at t. A little bit complicated, but once you get really good at completing the square and really good at understanding transformation of functions, then this question just brings the two together and you shouldn't have a problem. If you had any issue with this, obviously have a look at completing the square and have a look at transforming graphs and transformation of functions, and that will help you massively with this. Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it, and as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on, so it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean that it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC. And you can write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51. And the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away, what is it, 180 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. So let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles on a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB, and this time we're using the circle theorem that says angle at the centre, which is the 150. Is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now, if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you're doing this in the calculator paper, then please feel free to use a calculator. And we get 36 degrees. And again, it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones.
First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences we're interested in what it goes up in. So we're interested in what these go up in. So So if you've got a calculator, you can just do 25 take away 13. If it's on a non-calculator paper, then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right, the step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, all right, 35, it's 25, 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence. I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3. And that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. then you've got to find out what the linear bit of it is, and then just add them together.
Okay, so this looks like quite a complicated question. The important part of this question actually is this bit here. Now, this looks like it's trying to give you a little bit of help. Actually, it gives you a huge amount of help. It's basically telling you that when you add them together, the common denominator will just be a quadratic. Now, it might be tempting just to multiply all of this by all of this and kind of get a cubic equation, but actually the answer is saying no, don't do that. The bottom will work if you factorize it. So what we need to do is factorize the one on the right, and hopefully we will notice something about it. So we've got videos on how to factorize quadratics where a is more than 1, and it's quite a unique method, but I'm going to go through it quickly, but please use the videos for a kind of slower explanation. So what I do is I times together the first and last ones, times them together, and that gives me 48. And then I've got to find a factor pair of 48 that adds together to make the coefficient of the x. So 2 and 24 won't work, 3 and 16. So then I rewrite the 19x as 16 and 3, or 3 and 16, doesn't matter. You get the same answer eventually either way. Then I just look at these two and factorize them linearly, and I just factorize those two linearly. So 8x squared plus 16x, so I can divide out an 8x, and 3x plus 6x I can divide out a 3. And you notice that the bracket here is the same. Then you pair up the bracket that's the same with the bits on the outside, so you get 8x plus 3 and x plus 2. Cool. So I can rewrite that. Now I'm going to rewrite the question. So now it becomes 1 over 8x plus 3 x plus 2 plus 1 over x plus 2. Now you notice that actually that bracket is the same. So all I need to do is times top and bottom here by 8x plus 3. I'm squishing it a little bit. And it will have a common denominator. Right, so I'll rewrite that just to make sure my working out is really clear. So the top becomes 8x plus 3. And the bottom actually is the same as the other side, which is good because now we can add the tops together. So if we add the 1 to the 8x plus 3, we get 8x plus 4, and then we've got 8x plus 3, and then x plus 2. And that's my answer. Okay, so this question seems really easy at first, but there's a bit of a gotcha in it. So the first thing I'm going to do is just calculate, click the wrong one. I'm just going to calculate the total length of this line here, because I think that will help me for later on. So that's going to be 35 centimetres, and the other one will be x plus 7, so that's not going to be helpful writing that down. Okay, so we've got two similar triangles, which means one's a direct enlargement of the other one. And so this seems quite a simple task relatively. So that 5 there grows to 35. Okay, and to do that we do, well, to work out the scale factor, so scale factor. So the 5 to the 35. The scale factor is going to be 35 divided by 5, which is 7. So scale factor is 7. So therefore this one here, to go to the larger length, which I can highlight, and just kind of, there's blue here, we're going to times that also by 7. So if this times this by 7, then this one will times by 7, so that will be 49. So x plus 7
the whole length would be 49. So to find x, it's just going to be 7 less than that. So it's just going to be 42. So x is definitely looking like it's 42. However, it does say there's two possible solutions. One of the flaws that we've made is that we've assumed that the 5 corresponds with the 35. That this length here corresponds with the total length here. However, that's an assumption that we've made because it kind of looks like it does. And we're kind of used to questions where it does, because normally we know that these two here are parallel and therefore it definitely would. But there's nothing in the question that says these two are parallel. So it could be that this 7 centimeters here is the one that corresponds with the 35 centimeters here. So we've got to then run the figures again. So it could be that the 7 corresponds with the 35 centimeters. So the scale factor then would be 35 divided by 7, which is 5. So if the scale factor is 5, then we're going to look at this top one here, the 5 centimeters here, and times that by 5 to get to the x plus 7. So it'd be x plus 7 equals 5 times 5, which is 25. And then take away the 7 both sides, which would be 18. It's very, very difficult to get your head around that because it's so convincing that these two lines are parallel, but they're definitely not. And the hint in the question, in this one anyway, is that it's saying that the diagram is not drawn accurately. And in the exam, if they ask a question like this, you'll notice that the two lines here are going to be subtly different sort of slants on them so that it's not too misleading. But yeah, very, very difficult to spot, and sometimes in the exam you'll have questions like that. You just need to try and think through what assumptions have you made and are you right to make those assumptions.
Okay, so this question's all about iteration, and basically an iterative formula or iteration formula is one that gets you closer and closer to a solution. It will never quite get there, but it gets you closer and closer to a solution, or it gets you further and further away, and some of them do. So you will always be given an iteration formula if you're asked to do iteration. So we're given one here. To get to the next number, we do 13 minus root x. So that tells us how to get to the next one, the closer answer, and normally these will get closer and closer, otherwise it's very silly to do it because you'll just end up with very big numbers. So it tells us here to start at 2. It says, right, start at 2 and then work from there. And the iteration formula or iterative formula tells us how to get to the next one. Now, have your calculator out because it's a calculator question. I'm going to ask you to do something weird. What you're going to do is you're going to press 2 and then equals. Now, it equals 2, so the calculator just says 2. But this next step is actually pretty clever with these calculators. You can type in 13 minus square root answer. And on calculators it's normally ANS, or some of them they write the word answer. Now when you press equals, it will give us the answer, so that's great. So you might need to press S to D to make it a decimal. So we write down the answer, 11.5857 blah blah blah. But the clever bit is, if you press equals again, it will give you the next answer. So this time 9.596 blah blah blah. And just keep pressing equals. 9.9022 blah 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 blah. Equals again. 9.85321 blah blah blah. Equals again. 9.86, it's getting close, you can see. Equals again. Now you might be wondering where we stop.
Well, it says it wants 2 decimal places, so we stop when we get the same rounding. Now, you can see here that both of the last two would round to 9.86, so we could stop now, but I'm just going to go a little bit further to see what happens. And you can see again, every time you press equals, and you can just keep pressing equals, it will just get closer and closer to a number. Now, it might appear on the calculator that it stays at the same number at a point, but actually the number that's changing is so far down the stack, or so far down the decimal places, that you just can't see it anymore when you press equals enough. So my answer will be 9.86, but like a lot of questions on the exam, it's the working out that gives you the mark. So you have to show all the stages, your x1, your x2, your x3, x4, x5, x6, and then we did the next 7 just for the heck of it.
I hope you enjoyed that video. If you liked this video, please click like. If you really liked it and want to support this channel, then please click the subscribe button. I can never say that properly. Thank you very much.